Good morning. Welcome to Academy YouTube channel of Badri Prasad Group of Institution. I am Sachin Kumar Satpathy. Today we shall discuss subject circuit network theory, and my topic is series parallel circuit. So in previous class we can discuss the Ohm's law. That is, according to Ohm's, resistance is a property of a material which opposes the flow of charge or flow of current. So this resistance does not allow smooth flow of charge or current. Hence, the symbol of the resistor is a distorted path, that is not a smooth path. That means it opposes the flow of charge. So a resistance, this is the symbol of resistance. The symbol of resistance contains 2 points, A and B. That means the A point is known as the starting end and the B point is known as your finishing end. So every resistance has 2 points, that is, one is your starting points, another is your finishing point. So this is the resistance symbol, and it is represented as R. It is represented as R. So now we discuss about series circuit. So in this series circuit, what happened? Now the two resistance, let us two resistance R1 and R2 are connected in series. So in this series circuit we connected two resistance as a series. So in the series manner it is so connected that the dissimilar ends are connected together. Dissimilar ends means the finishing end and the starting end. So one resistance finishing end and another resistance starting ends are connected together. So in this connection we call back to back connection. That means one resistance will be connected to back of other resistance. So in this case what happened? The dissimilar ends are connected together and the other two ends are connected across a voltage source. That means the voltage source is V. In this connection there is the peculiarity is happen. What happened? That is, in this case voltage is divided. Whatever the voltage is applied, that may be divided across each resistance equally. Equally means according to the proportion. That proportion should be decided. So in this case voltage is divided but current flow is same. As the path of current is, as the flow of path is one, that's why the current flow is single. So there is a characteristics in the series connection, that is what? In this case voltage is divided among the each resistance according to proportion, that is not equally, that is according to proportion, and the current flow is same. So we can now decide it whatever the total resistance in the series combinations. So let RS, R subscript S is the total series resistance, is the total series resistance. So we the voltage, that voltage V applied, that voltage V applied is divided among the resistance R1 and R2. Let the voltage V1 is the voltage across R1 and the V2 is the voltage across R2. V2 is the voltage across R2. So total voltage V will be divided V1 and V2. So we can write V is equal to V1 plus V2. So we can write V is equal to V1 plus V2. So, and we previously taught Ohm's law. That means according to Ohm's law V is equal to IR. So we can replace V in place of V, that is V is equal to I into RS. That means V is the total voltage and the current I is the total current. So total current into the series combination resistance RS. So I into RS. Again in place of V1 we can write, that is according to Ohm's law, I into R1, that is the current I and the resistance R1. That why? Because the V1 is the voltage across R1. Similarly in the V2 is the voltage across R2. So in place of V2 we can write I into R2. As I is common factor for each term, hence I will be cancelled out. The net resistance RS is equal to how much? R1 plus R2. So according to Ohms, that is V is equal to IR, that should be put in the expression and we can get RS, series resistance RS is equal to R1 plus R2. So what happened in the series case, the total resistance seen across the circuit may added to each other, Now we shall discuss the voltage division rule. This voltage is divided among each resistance. That voltage how much will be divided, that should be now we calculate. That is called voltage division rule. In the circuit we know I is the total current and V is the total voltage. In the circuit I is the total current, V is the total voltage. So in the circuit we can write I is equal to what, how much, voltage by total resistance, that is according to Ohm's law. So we can also find out Rs is equal to R1 plus R2. That's why in place of Rs we can put R1 plus R2. So how much the value of I? Now I is now V by R1 plus R2. Now we can find out the V1 value in terms of V. Now we can find out this V1 value in terms of V. So now we can put Ohm's law, that is V1 is equal to IR1. That is V1 is equal to IR1, and in place of I we can put this value, that is V by R1 plus R2. So now what happened the value of V1? Now V1 is equal to V into R1 divided by R1 plus R2. That is the total resistance. That means when this voltage divided in among the resistance, so the factor that divided is total voltage into that resistance, divided by total resistance, that is V1 is equal to VR1 by R1 plus R2. Similarly, we can find out also value of V2. That means how much factor V will be demanded above the R2. So now we can written that V2 is equal to V into R2 divided by R1 plus R2. That is the V2 is factor of VR2 of total voltage. So